Just got a quick video on parabolas here for you. So first of all, we'll start off with what is a parabola. So a parabola is a symmetrical open plane curve formed by the intersection of a cone with a plane parallel to its side. So I have a little drawing here, a little diagram. So here we have our parabola. And as you can see, like I mentioned there earlier, it has to be parallel to the side of the cone. If it's not parallel, it can come out to be one of these other shapes. So it could be a hyperbola, a circle, or an ellipse. But the parabola is parallel to the side of the cone. So here I've just got a rough drawing of a parabola. So I've just got the different parts labeled. So we've got our vertical line up and down here. This is our directrix. It's just sometimes labeled DD or AB, like I've labeled my small parabola down here. Coming perpendicular from the directrix, we have our axis. This is the center line of your parabola, and your parabola is going to be symmetrical to either side of that. You've got your vertex, which is always the top point of your parabola, or the point where basically just the point of the parabola meets. And you've got your focus here, and your focus is where all your points when creating this parabola will be coming from. So down here I have one method of creating a parabola. So I've got my AB, my directrix, I've labeled it AB, and I'm always given my point C, which is my focus. So in this case my focus was 30 mil out from my directrix. First thing we had to do was find the vertex. So to find the vertex, we bisected this line here between A, B, and C. So I bisected that, got my vertex. That is the point of my parabola. From there, I took a series of circles from my focus. After each time I took the radius of these circles, I keep the same distance of my radius and mark it off here parallel to the directrix. And I take my line parallel to my directrix. Where they meet here and here, where they cross over the circle, they're going to be 2 points on your parabola. And I did the same thing 3 times to get 3 different points on my parabola, taking the same radius from my circle and bringing it from my directrix to find these points. So that is one method of forming your parabola. A second method I have here is using your rectangular box. So we start off with just our outside rectangular box. We divide that up the middle. This will make it symmetrical. Like I mentioned earlier, a parabola is a symmetrical shape. So we have one side of it and we have our other side of it. So to create this, the first thing we start off with is marking out our vertex, because this will be the point of our parabola. From there, each half of the rectangle divided into 4 spaces. You just have to keep each side the same amount of spaces. So I've got 4 spaces here, 4 spaces here. So with my 4 marks here, I was able to get my 4 marks here, and with my 4 marks here, I was able to get my 4 marks here. With the bottom points, I brought them parallel up. All these lines are perpendicular to the baseline, so they're brought straight up. My side points here are all joined back to the vertex. And then to find the points, I've labeled 1, 1, 2, 2, 3, and 3. And to find my points for the parabola, you just match up 1 with 1, 2 with 2, 3